So, welcome to module 12.1. So, we are on the doing the Jack compiler code generation. Hope you finished the part of the project which we decided to do as a part of towards end of module 11, and hope you are able to generate the symbol tables. And now we will just proceed. So, there were 3 routines that were left, and then there are some small changes that we need to do. I just left it as a simple exercise. I hope you would have realized those changes. If you have not, then these are some small bits and pieces that you may miss while you are writing a compiler. I just left it as a case study of how common mistakes could come while writing a compiler. So, there are some small 3 changes that we now in the compile if statement. This was dealt in great detail in the previous module. The only change is that instead of neg, as you see, I am just moving the browser here. So, instead of neg, we need to have not, right, that is the only change. The second thing is that if I take an if statement, what is the so if statement is nothing but if some expression followed by statements, right. So, this is a recursive call. So, again statements will call if statements. So, there can be a if inside an if, or there can be a if inside an else also, right. So, this is basically that is why we call this as a recursive grammar, right. So, a if statement can still invoke another if statement. Now, what we have done in the case of if statement is that we had one label. So, only issue now is the label num. So, the label, if you look at the previous, so we had one label num that we were using it continuously across this, but then if I use a label num and then that label num plus 1 etc. are going to be called. For example, you are going to, when we are processing an if statement, we are going to call again compile statements here. So, we have a label num, and that label num we are going to use after the compile statements, right. So, the label num plus 1. So, this compile statement can change the label num, because this compile statement can again call if statement and it can change the label num. So, the label num that you will be getting here will be different from the label num that we have taught here, that should be there. So, this label num can be changed by this compile statements. We have not assumed that that change will happen, right. So, since label num is a global variable, every time this if statement is called, that label num is getting changed, and since this if statement can essentially call statements which can again call if statement. So, by the time, and that will be part of your compile statements, by the time you reach this part, your label num can be different from the label num that we have already seen here. So, what we do is when we enter if statement, we have a local variable called t label num, and that you assign to label num and increment your label num by 2, and all your label nums you replace it by t label num. Here also it should be replaced by t label num, right, and here also very important, right. So, right. So, this label num, and so this also should be replaced by t label num. Right, all your label nums should be replaced by t label num, okay. Right. So, then every time, even if the if statement again calls compile if statement, since this t label num is a local variable, every avatar of this if statement, every time this is called, your t label num will be a different local variable, right. So, it will be a, so this consistency will be met. The same thing with while. Again in while we had used neg, that should become not for obvious reason, because we are just trying to negate. So, we will have true, it should become false, or false, it should become true. So, that only not will do that. And then again here while we enter this while, define a local variable t label num and assign it to label num and increment your label num by 2 immediately, and everywhere in the code use t label num, okay, rather than this. So, this will take care. The while can actually call another while, because while statement is a part of statements, and when I call compile statements, again while will be called, and this label num and this label num can be changed, because once this compile statements call another while, if I use label num, it can basically change. So, I need the same label num across one call of that while statement, and that can recursively call while again, and it can change, right. So, these two are the changes. So, just to sum up the changes, in your if statement, we need to make this neg as not, and then introduce a local variable called t label num, assign it to label num at the start and increment label num by 2 at the start itself, and everywhere in the routine make it t label num. Wherever you have seen label num in the past, make it t label num. Similarly, the same thing you should do in while statements, right. Again, in while statement, this neg replace it by not, and then t label num is equal to label num, increment label num by 2, again it is a local variable. So, every time this while statement or if statement, compile while statement or compile if statement is called, this t label num will have its fresh avatar. So, it will, so again everywhere you see label num, replace it by t label num. So, these two are the simple changes that you need to do for your whatever you have done in the previous week, and now we proceed. Okay. The next statement is compile do statement. So, what is compile do statement do? This is compile do statement. So, the do statement is do followed by a subroutine call, and always this subroutine call will be a method. Okay. So, how does a subroutine call look? It will be a subroutine name followed by an expression list. That means it is part of the same class that you are doing, right. So, I am in a class, I can call the subroutine of the same class without anything, or I could call a subroutine of a different class like array or math, etc., keyboard, etc., or I could define my own class, and that class I could initiate here, and I can call that dot subroutine followed by an expression list. So, basically this is how a subroutine name is here. Okay. So, I am just showing the laser pointer here. So, the subroutine call will be just subroutine name with an expression list, that is going to be part of your same thing. This subroutine name will be part of the same class. So, when I am compiling a function within the same class method or inside, I can use a subroutine of the same class, or it can belong to some other class. So, that name it will be class name dot subroutine name or var name dot subroutine name. For example, math if I say math dot abs, if I say math dot abs, then this is a class name followed by a subroutine name. Suppose I have said like var say some ball t, right, and I say and the ball has no move, t dot move whatever, then this t is a var name, okay, of some class ball, and so t is an object of type ball. So, t is a var name, it points to an object, and that dot move. Okay. So, this is the thing. Okay. So, okay. So, this is the way we basically look at this subroutine call. Okay. So, what we do first, we need, once you do compile do statement, first we should check for keyword do, then check for some identifier and call it ID1. This ID1 can be a subroutine name or a class name or var name, right. Then you go and check for the symbol dot. If dot is there, then your ID name has to adhere to the second rule, that is class name or var name dot something. If dot is not there, then it is just a subroutine name. So, if the next, after you check for the ID1, if your next symbol is dot, if yes, then you need to do some action. If no, then you do these 3 steps. What? So, ID1 is a subroutine of the current class itself. So when you are executing, so first I have to do push pointer 0 because I need this, because this will use the same class. So I need this, so I say push pointer 0, then I check for the symbol this thing, then I should see opening parenthesis, I should see expression list, then I do np equal to compile expression list. Okay. So the expression list will tell me how many number of expressions are there, right? Now how many expressions are there in this list, so how many arguments are there, we will just see what is compile expression list. So how many arguments are there, so this will give you the number of arguments, then at the end you should see slash expression list and then followed by the symbol this thing and followed by the symbol semicolon, right. Then you dump this code, class call class name, this is where you use the current class name because it belongs to the current class. So you have a global variable called class name which is the current class, so that you use it here, class name dot id1, id1 is the first thing that you have seen here, np plus 1, np is the number of arguments in the call, right, plus 1 because you have already pushed this. So this is basically number of arguments which will be np plus 1. And after you finish this, since this is going to be a do statement, this is a subroutine call, but every call as per our VM has to push something onto the stack. So something will be pushed by the subroutine call, the called subroutine. So I just say pop temp 0, essentially it gets, okay. So this is for a subroutine which is belonging to the same class, right. So these are the points that you need to do. Now let us go and look at if there is a dot, this is the second part, that is I say I am either getting math.abs or say some t.move, whatever, okay. Now I will check for the identifier and call it id2, right. So I will check whether there is an identifier id2, so id1 will be the class name, now I am seeing a class name or var name, id2 will be the subroutine name now, right, because I see a dot here, so I am in the second part of this rule. So now check if id1 is in local or class symbol table, in the local in the subroutine symbol table or in the class symbol table. If yes, then id1 is an object of a class. For example, if you have var ball t or field ball t, then it will be, then surely it is an object of a class, okay. That means it is a var name, right. So we will get its kind and type. So we put a code here, push kind type, okay, right. If no, then id1 is a class name, okay. So because you have to push kind type, this is because I am pushing the this of this, because when it's a var name or a class, it's a var name, then I for that object, that object's local variable should be accessible to the move, right, that object's field variable should be accessible to this move. So I just say push kind type, this is equivalent to pushing the so when in the called subroutine, the first argument would be that of the object. So I should, when I say t dot move, again when move is executing, it will access the field variables of t, correct, we have already explained that, and so that subroutine should have an access to the t, to the segment storing the field variables of t, and that is what we are pushing here, because push kind type will push the address of the starting location of t, right. And if no, then id1 is a class name, it will be like array, string or keyboard math.abs, okay. Then you come here, then you see you should see a symbol start parenthesis, left parenthesis, you should see expression list, then you do compile expression list, you call compile expression list and it will return an integer which will be the number of expressions in that expression list, and you should see slash expression list after that, and then this closing symbol and then semicolon, this is the last bit of this, and then you come back. If id1 is in local or class symbol table, that is if id1 is a var name, then call the type of id1 dot id2 np plus 1, okay, right. So this is what you need to call. So I need to call ball dot move, right, because ball dot move, and NP plus 1 because you are having the this of that. Okay. So if I have var ball t and I have t dot move, the code that they were put in the VM is call ball dot move with NP plus 1. NP plus 1 is number of parameters plus 1 for the this. Then again pop temp 0. If no, that means it is some math or array or keyboard, then you say call id1 dot id2, right. So math dot call math dot abs and np, because here in this case there is no need for pushing the kind type, and then pop temp 0. After it returns, then you have to just do pop temp 0. So this is how we do this subroutine call, right. So this is how we compile the do statement, right. So carefully go through this once, and then if you have any doubts, do put up in the discussion group, and we will clarify any more doubts in this direction, right. So a small change again here. Okay. This should be reading subroutine or class symbol table. Okay. So this is about compile do statement. Now we will move to the next module. Thank you.